3.5 Inverse Functions Part 1. So just doing a little quick algebra review, it'll be helpful for this lesson. So solve for x in the following equations. So I would add 4 to both sides, so we have y plus 4 equals 3x, and then I would divide by 3. So x would be equal to y plus 4 over 3. The next one, I would multiply both sides by 2, so I'd have 2y equals 3x minus 5 plus 5 plus 5. So I have 2y plus 5 equals 3x, and then we would divide by 3. Next one, I'm going to erase this. Next one, I would get the x squared by itself, so I would add 5 to both sides. So I have y plus 5 equals 3x squared. I would divide by 3, so I have y plus 5 over 3 equals x squared, and then I would square root it, remembering to do the plus and the minus. And the last one, very similar, we would minus 4 from both sides, so we have y minus 4 equals 2x minus 3 squared. Divide by 2, so we have y minus 4 over 2 equals x minus 3 squared, and then I would square root it, remembering to take the plus and minus of it. So I have plus or minus y minus 4 over 2 equals x minus 3, and then I would add 3, and I would just write it out in the front like that. So this is going to be helpful when we're dealing with inverse functions. So what an inverse function is it's the opposite, basically. And what we do is we invert the x and the y values, and then we solve to see if they're an inverse. So we're going to do it graphically first. So let's do function f of x, or I guess I don't need f of x, I could say y. Y equals 2x plus 4. Let's make a quick little table of values. So we have x and we have y. Let's go negative 4. So negative 4, if I plug that in, negative 4 times 2 is negative 8, plus 4 is negative 4. I have negative 1, plug that in, and I would get 2. Let's just graph them so we're not finding random points. This is going to take forever. So we have a y-intercept of 4 and a rise and a run of up 2 over 1. So my first line looks like this. And then I have a second line, and it has a y-intercept of negative 2 and a slope of up 1 over 2. Or down 1, left 2. And it looks like this. So what you should notice is they're crossing right here. So that's an invariant point on this. And what you should also notice is that it's symmetrical, and the reason where it's symmetrical is right here on this diagonal. And the equation of this diagonal is y equals x. And it crosses where it crosses that line. So where it touches this y equals x line is where both lines are going to cross. That's where that invariant point comes. And what you should also notice is that the distance is similar between the two of them. So I was making this table of values using negative 4 and negative 4. There's 1 point. I have negative 1 and positive 2. There's another point. We could go 1 and 6 is a point. We can go 3 and 10. That's a point. And what we should be able to notice is there's a similarity to the points on the other side. So first of all, the negative 4 and negative 4 doesn't change. Same point. It's where it hits that axis. We are going to have a point that's equal distances from here to here, and that point is at 2 and negative 1. we're going to have an equal distance point here to here. And that point is at 6 and 1. And we also have an equal distance point from here to here. Looks like a spider web. Cool. And it's 10 and 3. And what you notice now is that those points are the same, but they've been inverted. So our x values and our y values are inverted to find this. So that's what an inverse function does. It reflects on this y equals x line. The distance between the line and the point on the function will be the same between them. That's how you can tell that it's an inverse. And our x and our y values will just be the opposite. So let's use this knowledge to graph this. So our domain is from -4, I don't know, I wrote an x there, -4 to 3. And our range is from -1 to 4. So there is our domain and range. Let's look at our points. So we have f of x. We've got the points. Let's go -4 and 4. We've got the point -1 and -1. We've got the point 1 and 3, and we've got the point 3 and 2, which means that on our inverse function, which is f of y, we're going to say our x is equal to our y values, and our y is equal to our x values. So we have 4 and -4, -1 and -1 doesn't change, 3 and 1, 2 and 3. So now we can plot these at 4 and -4, -1 and -1, 3 and 1, and 2 and 3. And it's important that you follow along going in the same order. So it would be from here to here to here to here, because that can be difficult. And if you were to imagine that y equals x line right there, it is symmetrical along that. So domain, so now our new domain is going from -1, and it's going to 4. And our range is -4 to +3. And what you should notice is that our domain and our range changed. They just flip-flopped. So that's how you do the inverse of a function. Okay, next example. Determine an equation of the inverse of y equals x squared plus 3. So doing this algebraically, first of all, let's graph y equals x squared plus 3. It's a parabola, and it has been translated 3 units up, and it hasn't been stretched or compressed, so it goes up with normal amounts. So starting at 3, and then we're going to go over 1, up 1, over 2, up 4, and that's all that we can really fit. Alright, so there's my original parabola. I'm also going to draw in the dotted line here for where it's going to be symmetrical. Just save some time, I guess. Okay. To find the new equation, what you will do is you will change places the x and the y values, and then you will solve for y to get it by itself. So I'm going to -3 from both sides, and then I'm going to square root both sides, and I'm not going to forget about the plus minus. So this is the equation of my inverse function. Let's graph our inverse function. So we have f of x. Let's do that in black actually. F of x. So we have the points -2 and 7, -1 and 4, 0 and 3, 1 and 4, 2 and 7. And I literally just got that from looking at the points we plotted. Here and here. To find our inverse function, so f of y, we're going to just flip the spots, so 7 and -2, 4 and -1, 3 and 0, 4 and 1, 7 and 2. So it would look like this. That's 8. Oops. So there is our inverse graph. Now we have to check to make sure this is a function. This is supposed to say f of y. So f of y is not a function. And the reason it is not a function is because it does not pass the vertical line test. So if you do not remember what the vertical line test is, which is from Foundations 10, it is if you were to imagine a vertical line, like a pencil or a ruler, and you were to drag it across your function, if it ever hits at 2 points, it's not a function. So see here at the vertex, it's fine, it just hits once, and then literally every other point after it hits that ruler twice. This original function is a function because it never does that. It only ever hits 1 point at a time. So it doesn't pass the VLT, it's not a function. What you have to do is you have to restrict the domain. And we're going to do the whole next lesson is on restricting the domain. So we're going to not do that right now, but just know that we have to restrict the domain. And what that means is we're either going to show it for this, or we're going to show it for the opposite. Because that's the only way we can make it into a function, is by making it the top or making it the bottom. But we're just going to move on from now, just practicing doing inverses, and then we'll get into that restricted domain after. So let's do an exact same thing here, just a different equation. So we've got this. Let's draw in the dotted line for the vertical. Okay, now let's graph. So our function f of x that we're graphing is -x² plus 4. So our vertex is going to be translated 4 up, and it's going to be opening downward now. So it'll go up 1, or over 1, down 1, over 2, down -4, over 3, down -9. So we can plot all of those points. 4, 9, 9. Okay, so there's my parabola. And we have the points -2, 3, -3 and -5, -2 and 0, -1 and 3, 0 and 4, and then 1 and 3, 2 and 0, 3 and 5, -5. Okay, let's find the equation first. So we're going to split the, or change the places of x and y. So we have x equals y² -y² plus 4. We're going to subtract 4 from both sides. So we have x minus 4 equals -y². Divide by -1. So we have -x plus 4 equals y². Square root. So we have plus or minus the square root of -x plus 4 equals y. So there is our equation, And when we plot this, we're just going to change the y values, so it's going to be -5, -3, 0, -2, 3, -1, 4 and 0, 3 and 1, 0 and 2, and -5 and 3. And then I want you to pause the video and I want you to go and plot those. So you should get your graph looking like this. So f of y is not a function. It doesn't pass the vertical line test, and we would have to restrict our domain. Alright, so let's move on to inverse part 2.